The idea here is at least we want to be able to deposit, ultra thin conformal coatings that are pinhole free mainly, as for some of our applications. That's the main requirement, the pinhole free coatings, so that we could protect some of the more vulnerable films from exposure and decay. So that's where we are. And right now we have the 3 precursors installed: aluminum oxide precursor, and then we have hafnium oxide, and then platinum. Okay, so this is how the system is set up. So we have the ultra high purity nitrogen here. This is okay. So we have nitrogen cylinders right there, and at this time we are using a air compressor, but I think we have to change that because now we have, at that time we do not have compressed air in the lab, so we have to use an external compressor. I think that needs to be changed. So we have that set up as well, and we have the dry pump, and yeah, that's it. Okay, so you want us to manually switch off the nitrogen then? Okay. Okay, so I'm turning. So I think I'm turning the water. Yeah. Okay, the nitrogen is off. I'm not gonna change this because that's the flow or that's the pressure. Now I'm just with that all the time. And then I'm turning the system on. Okay. Should we turn the pump? Then the pump is on. And on the pump you have some readings. Let's see what we have there. So for the pump, if you notice, we have some readings on the pump. Is that the set points that we can set up on the? Okay. So the system is turning on now. Okay. So I'm gonna turn the heaters on. So the temperatures that I've set for the chamber is 120 degrees. Again, that was what was suggested on in the manual. 150. Okay. Okay.
And then you're going to go ahead and turn those on.
Sorry?
Go back to it.
I'll go back
Yeah.
to the heaters.
Turn it on.
Oh, yeah, you're right. Okay. So this. Okay.
This will show you a chart of temperatures. And you
Okay.
can see that it's just rising on the left side. And then if you click display on and off on the bottom left,
Yeah.
it'll take a power output of each of those.
Oh, I see. Gotcha. And what do we have here? Yeah.
And that will be a graph of the general temperature.
Left.
Okay. Where is it? Oh.
The heat is light right now, so it might not
Okay.
display the graph yet because it is still cold.
Okay. So I'm gonna exit the screen.
So in order to start a recipe, if you're going to be running the same precursor, you can go into custom recipe.
Okay.
So if you select custom recipe, So if
see.
you are going to be running the same exact process every time, this is a really great screen just to easily start that off. And so here you can see it gives you all the parameters of different types of recipes.
Mm-hmm.
And so for this one that I'm going to show you, I'm already seeing something you set up for testing already. And so, it already has the same options for temperatures, for precursors, and pulses will be the number of pulses. And then the purge times.
Okay.
And then these already go through the cycles. For example, for like aluminum, we usually see on like 1 angstrom per single growth rate.
Mm-hmm. Okay.
Now anytime you want to run a recipe from this screen or another screen, you have to set the file name.
Have to set.
So see how the recipe
Okay.
box is like Thar right now.
Right.
That's because you haven't set the file name yet.
Gotcha. So you have custom 1 and custom 2. Why do we? Yeah. Go ahead. Go ahead.
Custom 1 is just like, you have that one recipe you will be using all the time, and then if you also plan to use another recipe a lot of the time, you can write that one
Okay. So
into
these are
the.
more like a default recipes. Okay. Okay. I see. I see. Okay. So that was from the
Recipe.
custom recipes. Okay.
You can also save your recipes by going into Load Recipe.
Mm-hmm. Yeah, we have few.
And this gives you parameters that you can go in and put in yourself. So if you're changing what you're doing a lot, you can recall the recipe from here using the bottom fields.
Okay. Let's see. So we have fixed recipe names. So these are all the recipe names. And if I want to go into that, how do I do that? Do I?
You just view it from this screen, but you can scroll to the top and see all the parameters, and then you can edit it. You select Edit from the top right.
Oh, okay. Edit. Okay.
For example, like in line 5, you can just go to Edit on, and then select each field and then input whatever parameter you want in there.
So we have these are the recipe names. Let's say I want to change hafnium oxide.
We're going to go to Edit
Edit
on, and then you just click whatever parameter you want to change.
Oh, okay. Okay, I see. Okay.
Again, in order to run the recipe, you have to set the file name.
Where do I do the file? Okay, here. Okay. So should we do a file name for TMA anyway?
Just keep that because that is your recipe name, but I will do the file name with you in the other recipe screen.
Okay. So
Then, through this page, you can also go into a multi-layer recipe. If you look at the bottom right,
oh yeah.
and the multi-layer allows you to call your recipes from that loaded recipe screen and make a multi-layer process of different metal oxides if you want to. So
when I'm running the multi-layer, would it automatically purge the lines before it introduces a new gas, or?
you would do like 3
Okay.
layers of aluminum, for example, and then you do like 3 layers of TMF, and then it would repeat that pattern, basically, and it would say do it again.
Gotcha. Okay.
So this is just another option for trying to deposit multiple materials or deposit multiple things.
Okay.
So
Okay.
now just exit the screen to check
Okay.
the
Oh, sorry.
temperatures. So the temperatures are still
Yeah.
rising, which might take a long time.
When you say manifold, so these are the manifold?
To the right.
The manifolds should be valves 1 through, like 3, and then on the other sides are valves
Oh, yeah,
5 to
here, okay.
7.
Okay, so you have we have water here. Can you remind me what kind of water are we using here? Is it like just the DI water, or is it?
Yes, we use DI water.
And I can refill it, right, with myself?
You can, but it should last you a really long time.
And how do I know that it's running out?
The way that you could tell if it was running out is, let's go see the next screen, and then click manual pulsing.
Okay, manual pulsing, okay.
Then click manual at the top. This allows you to pulse each valve individually, and so you can either do that if you're purging the line when reinstalling a precursor or changing the precursor, or just if there's something wrong with the pulse. Then you can troubleshoot through this.
Gotcha.
So for example, the pulse time is really long right here because it is not doing much. But if you suspect that the water is low, so if you pulse valve A4, then the water vapors release into the chamber and you will see a pulse normally, but then if there is no water, then you won't see a pulse. There should be nothing there.
Okay, okay. Yep. We all established.
So basically, this page is really great when you're just watching a recipe. It gives a great visual of where the gas is traveling to and what the pressure is, so you know which gas is actually being used in the chamber. So, for example, when we start this recipe, you'll see that it pulses it to valve 5 for the TMA, and then we'll pulse it to valve 1. And then we'll go into the chamber, and then you'll see the pressure all within this screen. And as the recipe is running, you'll see the valves will have little red dots to indicate that they're open.
Okay. Now, my other question is, so this 150 that's the temperature of the chamber, right?
We calibrate the temperature of the chamber that it's actually, let's say, 150. We calibrate it at the wafer temperature to 150.
I see. So that means if I want to do a low temperature aluminum oxide layer, I won't be able to do it?
We'll be able to. So, the default that we have on our system is every time you run a recipe, it will have a standby separate temperature turning it on. If you are running a lot, the system is happiest when it's just left on and undisturbed. Constantly purging, having the temperature stabilized, because it can just take a while to have the temperature stabilized by turning it on and turning it back off. We recommend just leaving it at a set standby temperature until you're ready to use it. So, if you go to the setup page.
Okay. Setup. Okay.
You can see that on the right side, there's the chamber set standby temperature. So if you wanted to do room temperature, you could set that.
Oh, okay. Okay.
And then, oh wait, actually, change the at the top where it says the pre-process purge time. I'd change that to 10 to make sure everything stabilizes.
Okay.
That's our default and what we use here.
Okay.
I would recommend that anytime you're running a recipe with a heated source, to increase your pre-process purge time, especially if you're also turning on that bottle heater for that precursor. That helps bring it to a stable temperature.
Oh, I see. Okay. So right now we are not really running TMA at a high temperature, right? TMA is the
No, that one's just at room temperature.
precursor 1, 2, and 3. Okay, precursor 1, 2, and 3, 4, and okay, 5 is also. Okay.
If you go back now.
Okay.
So now we've gone through some of the pages. Nitrogen is off. So
Yeah.
we need to purge that line. We can do that by setting the nitrogen from 50 ccm to control the flow. That's on the left. That's how we manage the nitrogen flow.
Right. So right now the nitrogen is off. Yeah.
Set that to like 200.
Okay, so I set it to 200. And I can see the pressure increase.
The pressure rising is just part
But-
of the purge process.
Right, because the nitrogen is off, right?
But then it should drop back down and the pressure
Okay.
will stabilize again.
How low would it come?
Just set it back to 10 ccm.
But
And then feel free to turn the nitrogen back on.
you can turn the nitrogen.
To 1520 psi.
And that 15 to 20 psi, I'm controlling on the on the cylinder itself. So right now, the nitrogen is at 20 psi, and then we are doing 10 SCCM of nitrogen.
Perfect.
Okay. So basically, we are flooding the the lines, and then where is the nitrogen coming from? Let's see. From here, where is the nitrogen? Okay, here is the nitrogen, right? That's the MFC, and then
There's no actual visual line on this screen for the nitrogen,
oh, okay.
and
Okay.
it's just a rough approximation.
Okay. So when I turn the nitrogen on, should I see the pressure go up again?
This is pretty typical. But if you, for example, if you increase the flow to like 25 cccm, then you should see the pressure rise. So it's pretty good.
Okay. Okay.
So you've already installed precursors, right?
Yes, the precursors are all installed. Yeah. And yeah, it's under vacuum. The chamber is under vacuum.
So the next step would be to write a recipe.
Okay. Why don't we start from the scratch, as in, let's say we are trying to run a new recipe. How would I do that, right? So that way,
Okay, if you want to write a new recipe, so like we talked about, there are different ways you can run a new recipe through the custom recipe screen. But once you run that recipe, it doesn't automatically save it. You have to manually save it if you want to keep it. Does that make sense?
gotcha.
So if you load a custom recipe one and then change it and then want to go back to how it was before, you'd need to save the original first.
I see.
The
Okay.
custom recipe option is just a quick way to set things up. It doesn't save changes unless you do it manually.
Okay. So do you want to do a custom recipe first as an example, and then we can do load recipe next? Is that what we should do? Okay, so custom one. Go ahead.
Your current custom one is already a good starting point.
So the deposition temperature is 150 degrees Celsius. So what does that mean? The deposition temperature, as in the chamber temperature?
Yes, it's the chamber temperature.
Okay. Static high exposure? No. Okay. Exposure time. So this is something that we have to set, right? Or
You would set that if you're aiming for deeper film penetration. The process traps the precursor in the chamber before purging with nitrogen. So it has a longer exposure at the surface.
I see. So if I want to, yeah.
For TMA, this looks fine.
Okay. Okay. So precursor A, TMA. Okay. So we got that.
You're probably going to have to click TMA again.
Yeah. Number of A pulses, 3. Then the purge time.
How are you all measuring? Are you using ellipsometry?
Yeah, we could do ellipsometry, or we have a reflectometry tool as well that we could use.
So the purge times, basically for TMA, our standards are 11 seconds and 13 seconds. But if you find that you're not getting good uniformity, you can always increase the purge times.
Okay, so if I want to have better uniformity, so do you think I should maybe just keep it at 12 then? Just 12 seconds of purge time?
Yeah, 11 or 12 is fine.
Okay, let's do 12. Okay, so you have TMA.
You can make the purge times in theory as long as you want, but if you're trying to be more efficient, you can kind of have a starting point and then work your way down to an efficient purge time.
I see. Okay, so let's do 11 then. Oops, sorry. Okay, we got 11 set up. So we have number of A pulses. So is 3. What does that mean? So we are sending in TMA.
So you can take 3 pulses of the TMA. It will pulse 3 times,
Okay.
and then it will pulse the water.
But how long does it pulse though? Like how long does it pulse? 3 times.
I believe the dose valve, you can see it on the setup screen. You can actually change how long the pulses are between the dose valves and the manifold. I believe the dose valve pulsed setup is to be 650 milliseconds. And the manifold pulse is set be 550 milliseconds.
Okay. Okay, so that's that. So does it pulse? Yeah. Sorry. So you pulse 3 times and then you purge, or is it pulse, purge, pulse, purge, or what is the sequence here?
I believe it pulses the 3 times and then
Pulses 3?
purges,
Okay.
and then it pulses 2, and then it purges.
I see. So I can see that the water is next, and then the ozone is not on. That's okay. Number of B pulses is 2. Purge time is 13 seconds for that, and total number of AB cycles is 350. Okay.
Then you can put in however many of the AB cycles you want as well. It gets pretty thick, but I don't know how thick that you're planning on.
So 350 cycles, what do you think the thickness would be here?
It's probably going to be anywhere between like 30 and 35 nanometers.
Okay. Maybe for the first try, how long do you think it will take for 350 as in?
I know for 150 cycles is roughly an hour and 40 minutes.
Oh. Okay, so that obviously we cannot do that then. Uh, so the reason, I think the last time we did it, the reason was we were not getting any film, and then he wanted to see the film, so that's why we did that overnight. I think maybe we did it overnight or something. But what happened? Yeah.
Usually, even at 150 cycles or so, you may not see anything on the top, but you can see something on the back.
Oh, I see. Because last time what happened?
Usually that confirms that there's something there.
Okay. Because last time he forgot to open the precursor valve, so there was so that nothing happened.
It can be helpful to put a note for yourself
Yeah.
to be like, remember open or remember close,
Right.
because I've definitely
Right.
done it before. And you did the entire process.
Now, how do I? Yeah, I know exactly. How do I increase the density of the film? Like, what settings would I use to increase the density?
For that, you would probably want to use the static exposure.
Oh, the static exposure. Okay.
Yes, I don't currently have that for aluminum, but I can come back to it.
Okay. Oh, the static exposure here. Okay. And then total A and B. So, what do you recommend? 100?
Yep, just as a starting point.
100. Okay.
And just remember to set the file name
Set the file name. Okay.
to whatever file name or structure you want to go with.
Uh,
So what I usually do, it put the number of cycles of what I deposit and then the temperature.
Okay, okay. L2O 300 cycles, 150C.
And then hit enter.
Okay.
And then you are going to exit this screen. And then if you're going to load your sample, that would be the time to insert it.
Okay. Let's load the sample. That's venting.
It takes a little bit, but once it vents, it will stay vented under vacuum.
This is also displaying, so
Okay, that's vented.
And then all you need to do from here is go back into the custom recipe
Okay.
and click on Run Custom 1.
Run custom box. Okay, so we gave it a file name.
See the step status? You'll see the steps left to go.
Uh-huh.
So right now, it's counting down the pre-processed purge. So it's making sure the chamber is completely evacuated before it starts to process.
Okay.
And then after the 10 minutes, you'll see it running through the purge
Oh.
process.
I need to turn on the, we need to open the valve, right? TMA? Yeah.
That the precursor valves. So there's 3.
Okay, the precursor is open. Oop. Okay, so the precursor is on.
So it will just run the recipe. And then when it's done, it will say, instead of process running, it will say system available when it's done.
Okay.
And that's it.
How much time it takes?
So is it the total amount of time it's going to take? 8 minutes?
So that's just like the step time. So it's in the step of pre-process purge, but the whole process will take an hour and 6 minutes.
Oh.
And so in that step to go box where it's counting down, you see it like counting down the purges.
I see. And where do I check for the, maybe the pressure curves?
On the previous screen. As the recipe starts, once the recipe starts, you'll see valve 1 and valve 5 pulse it for the TMA. And then you'll see the chamber pressure. You'll see the chamber pressure increase.
Okay, so right now it's 134 millitorr because I'm purging it with nitrogen. Is that why it's so high?
Oh, she's gone.